Let f of x be cosine of x minus k, x is greater or equal than 0 and less or equal than a, and a and k are real and positive. A, consider the case where k is pi over 2 by sketching a suitable graph, or otherwise find the largest value of a for which the inverse function exists. First of all, let's consider the necessary condition, the inverse function to exist. The function should be 1-to-1 or pass a horizontal line test the inverse to exist. It should be like this. This function is 1-to-1. It means for one x value there is only one y value. Or if you draw a horizontal line at any point, you will get at most one point of intersection. It means you will get one or no points of intersection. If and such function will have the inverse, because if you plot the inverse, and how to plot the inverse, x becomes y, y becomes x, and finally this curve will be symmetrical about the line y is x, and it will be like this. And it's a function by definition. How to check whether some curve is a function? It should pass a vertical line test. If you get that at least at one point you get two or more points of intersection between vertical line and the curve, it means that such curve is not a function by definition. Or to be a function for one or for some specific x value, there must be only one y value. For example, if you consider y is x squared, it's not 1-to-1 because if you plot a horizontal line, it's enough for only one point. Where there are two or more points of intersection, it doesn't pass horizontal line test. And you can see that there are two possible x values with the same y values, so it doesn't pass horizontal line test. And such function doesn't have the inverse, because if you plot the inverse, it looks like this, and it's not a function at all. It doesn't pass vertical line test. And if for one x value it's enough to be at only at one point, if you get that for one x value there are two or more y values, it's not a function at all. It's called one-to-many relation. It's called a relation actually. And this is called many-to-one function. And this is 1-to-1. It means 1x, 1y. And now let's consider our cosine of x minus k. And we can obtain this graph from cosine of x by translating k units to the right. K is positive, and function of x minus k can be obtained from f of x by translating k units to the right. Cosine looks like this, passes through 0, 1, period is 2 pi, so it's pi over 2, it's 2 pi. And if it is translated k units to the right, and if k is pi over 2, it becomes translated pi over 2 units to the right. So this point, it's negative pi over 2 and y is 0. It becomes 0 for x and 0 for y. So it becomes 0, 0, and it looks like this. And this point 0, 1 becomes pi over 2, 1. It's here. It's quite clear. And this function, you can see that it's not one-to-one function. It doesn't pass horizontal line test. And to have the inverse, we should cut it so that it becomes 1-to-1. In general, we can consider this region to be 1-to-1 from this turning point up to this turning point. and from negative pi over 2 to pi over 2, such a function will have the inverse. But here it is given that x is greater or equals than 0 and less or equals than a, so we should consider the region greater than 0. So only this region, and we should consider x to be from 0 up to this turning point, which is pi over 2. So a is pi over 2. The next, find the largest value of a for which the inverse exists. For k is pi, absolutely similarly, but now it will be translated pi units to the right. So this point is negative pi 0. It will be here. It will be 0 0 at origin, and y will be negative 1, because this point is negative pi negative 1 is translated pi units to the right. It will be 0 negative 1 and usual wave, and it will be like this. And again, we consider x to be greater or equal than 0, and we should cut so that it becomes 1 to 1, and it will be up to this turning point. So it will be like this. And what is the x coordinate of this point? You can see that it's half a period, it's just pi. So a is pi. And the third situation, finds the largest value of a for which the inverse exists in the case where k is greater or equal than pi and less or equal than 2 pi. Give your answer in terms of k. You can see that it is translated by pi units to the right, and k is in between pi and 2 pi, and so when it is translated pi units to the right, this point becomes where x is 0, and when k is 2 pi, this maximum will be at x is 0, so it will be again cosine, because 2 pi is period, so it will be shifted by a period. So you can see it is this is translated by pi, but let's consider, for example, if k is some specific value, for example 1.1 pi. It is already translated by pi, and if it is translated 1.1, so it will be translated a bit to the right, so this minimum point will be a bit to the right, and again usual wave, and the inverse to exist, it should be 1 to 1, but x again is greater or equal than 0, so it's just this part of a graph. But what is x coordinate of this turning point? You can see that it is translated pi to the right, and additionally 0.1 pi, so it's 0.1 pi. This coordinate is 0.1 pi, and hence a is 0.1 pi. And in general it becomes when k is greater than pi and less or equal than 2 pi, it will be like this. This point is moving to the right, we're moving to the right, and this, it's a translation by pi, but we need k which is greater than pi, so it will be somewhere to the right. And this x coordinate, it will be k minus pi, because k is some value in between pi and 2 pi, and translation up to here it's pi, so this additional piece of a graph is translated by k minus pi, and the inverse to exist when x is greater or equal than 0 and less or equal than a, it will be from 0 up to this turning point again. So we can say that a is k minus pi. And when it's the necessary answer, and when k is 2 pi, it will be just usual cosine again. So this point becomes here. It will be here. And you can see that this answer will be true, because the required region, the inverse to exist, it will be k minus pi, which becomes if for example, if it will be the maximum possible value of k, which is 2 pi minus pi is pi, and you can see it's pi, so it's true. So the answer is A is k minus pi, and that's all for this question.